Hello, this is Benjamin. Tonight we're reaching into some old data. We've got the M27 Dumbbell Nebula here. This is an old edit I did with Pixinsight. It was one of my first Pixinsight. It was one of my first Pixinsight images, and I think I can do a lot better now. So I've restacked it, and I'm prepared to do it here on the right. This image was taken with a Nikon DSLR, a D850 unmodified, and a 200 to 500 millimeter zoom lens at 500 millimeters, so it was on a Skywatcher HEQ5 mount. So I did have the mount going with tracking and everything. So let's see what we can do. This data is undrizzled because I'll show you when we do a stretch, when we do a screen transfer stretch. You can see when we really zoom in that there are some artifacts on some of the stars, little black rings that got really bad when I dithered, and it turned into 183 megapixel picture because it was just a little bit too large to work with. So, but you can see some of this ringing. We'll deal with that the best we can. But this is at 700%, so zoomed out to 100%, it's really not too bad, but you can still see it at times. At least I can see it without the YouTube compression. So let's go ahead and do some editing. First thing I'm going to do, because we've got such a small target, I'm just going to go ahead and crop this thing down. So dynamic crop, let's do something. Do something about like that. Let's go ahead and do this as a square, because why not? 1750 by 1750. Okay. Alright, so the first thing we need to do is get this out of the way. This is our JPEG final image from before, in case you missed where that went. So I started using a toolbox script called Auto Linear Fit. We're going to use that today. It takes away this green bias. So we're going to take away the green channel. It just automatically does it for you instead of having to break it out and run the linear fit by hand. It does it automatically, and it does a fairly good job from what I've seen. So we've got that bias taken away. So now we're going to run a blur exterminator, correct only. This is kind of a new workflow that I've picked up and I've really started to like. So we'll run the correct only. Okay. Now we're going to run the automatic auto DBE script by SETI Astro. I don't see much in the way of a gradient here, but let's run it anyway, just to be safe, and we'll see what it took out, if anything. Here's our background, and if we stretch the background, you can see that it took out some abnormalities. So it took out some abnormalities for sure. That's interesting. And our new image looks like this. Our old image looked like that. So it's not much to the eye, but apparently took some. It barely found some. So let's just go ahead and close this. And this is our flattened image. So let's go ahead and solve it now. Let's do our best to solve it. It's hard to solve these DSLR images, but we should be able to do it. Image solver. It's got the date in for us, but our location is M27. Do a search for that. Dumbbell Nebula. That's interesting. M27. Let's see if we can solve this and get an astronomical solution. It looks like it's solving. Yep. We're going to get a solution. We're not getting a solution. Never mind. We got nothing. So let's go ahead and abort that, because that is not going to work. Yes, we want to abort. So in this case, let's go ahead and just run oops, still aborting. There you go. Let's go and run a dynamic background extraction. Background neutralization. Background neutralization. Let's find a nice little place to put a preview without too many stars, which is tough. There you can see some of that artifact. It's not just black artifacts, it's color artifacts, but we'll take care of that the best we can. Let's see, background neutralization. There's a spot. Let's put a preview there. Region of interest is preview 1. And let's run background neutralization. Okay. See, it just took out some of the red and made it a little more neutral. So let's go ahead and delete our preview. Now we're going to run Blur Exterminator in its full capacity. So we're going to go with the default settings for the moment. Actually, this is going to be pretty quick. Let's go to sharpen non-stellar all the way up and see what it looks like. This is going to run real fast. We don't want to have to pause the video. It looks... So what we're going to do is create a clone. Zoom in on the clone. To 4:1. Oops. Let's run it at 100% here. And we'll run it at default here. And I'd be lying if I said I saw much of a difference, in all honesty. So let's close our clone and go with the 100%. Okay, let's go to some noise removal with the Graxpert denoising at strength 1. And we'll let this run. You can see I really like this noise denoising by Graxpert. It just does a really solid job. It does as good of a job as Deep SNR, which is the new fad, right? Well, not fad. It's the new way to do things. But it doesn't create a whole bunch of white dots on my image, which it might be stars, but I don't think they are. I think they're artifacts. Still learning about that. So for now, I use the Graxpert denoising because it does just as good of a job without the white artifacts, what I think are artifacts. So Graxpert. We will go ahead and remove the stars now with Star Exterminator. Okay. Let's rename this to stars. And let's play with it. What do we got here? We've got... Let's go ahead and stretch them now. Transformation, turn off the stretch. And stretch them ourselves for good. I'm going to apply that again. That's a little bit much. We probably want to leave the stars a little bit low in order to not take away from the nebula. But it is in the Milky Way, so there are going to be a lot of stars. But let's leave it a little bit low, and we can always bring them back up later if we want more stars. But we really want the focus to be on the nebula, so let's not go too crazy on the stars. Let's run a reduce correct magenta stars. Let's run a SCNR green. SCNR, I forget what it stands for. Selective color noise reduction, most likely. And we'll take out the 70% of the green. And does that leave us with nice colorful stars? Yeah. I think those stars are pretty good. They're good enough for now anyway. Let's leave them alone. We'll play with it. I've got two very big errors here in the removal. I guess they're not errors because they're star problems. So we're going to use the new new tool from SETI Astro called Blemish Blaster, which is a content-aware clone stamp tool. If you don't know, so we're going to make it nice and big. We just want it to blend in with the background. We don't care. You know, we're not using it in a nebulosity region where it's actually going to invent structure and all that. I'm a little wary of the tool in some instances, but in this instance it's not a problem. It just is going to remove our two stars and create a background that looks good. So, alright, let's go ahead and start stretching this. We will use what I didn't use before because I didn't know about it, or it didn't exist, or more likely didn't know about it. Generalized hyperbolic stretch. Let's zoom in on this. Put a symmetry point right in the middle. Local intensity goes to about 1300. Stretch vector goes to about 5. We turn on the preview so we can actually see what we're doing. And let's see, let's take it to about there right now. So 3.48. Accept that. Let's put a new symmetry point on the graph. Stretch factor, local intensity. I really want to bring out these wings, the up and down wings that are so hard to get. That's what I really want to get. With the DSLR, unmodified DSLR, I think I'd be very proud to get that. So let's bring the protect highlights down so we don't blow out the core of the nebula. And let's go ahead and stretch it a little bit more. Local intensity a little bit more. Oops, a little more. Bring those protect highlights down more. And let's play with the symmetry point, make sure it's where we want it. Let's go with right there. Just seems to be the best balance of noise and signal. Let's accept that. Let's go ahead and actually click on the wing that we want to capture that, so that'll put a point on our graph right here. That's exactly where that signal is on this graph. So let's send that to the symmetry point, and let's bring that up as much as we can while pushing down the noise. Bring that out some. Pull down the protect highlights to protect the middle. Let's protect the shadows some. They're getting a little dark. Go right about there. Let's create some contrast in the middle of the nebula. A little bit too much, if I do say so myself. Play with the symmetry point a little bit so we don't blow out the wing that we're trying to get, or not blow out, but not hide the wing we're trying to get. Pull down the protect highlight slider, pull up the protect shadow slider because that is way too dark. Let's accept that. And let's go with that for the moment. That's a good... Actually, let's do one more. Let's do one more, and we'll do a trick. We'll do the mode to color. Try to bring some of that color back because we've lost some color. So let's stretch it, and you see how it brings back the color. And let's watch our... Yeah, that's not good. Leave the local intensity the same and protect highlights down so we don't lose our contrast. Protect shadows up a little bit so we don't lose that. And let's see what we... And it just brings back a little bit more color to it. You know what? I don't like these. I don't like this at all, actually. Let's take that away. We're starting to blow out the contrast. So let's just completely abandon this last stretch. Reset it and close it out. Close down our real-time preview. So see, we've taken it too far. You can see how it's kind of like real flat and just color right there is real flat. Let's see if we take it back a step or two. Yeah, just take it back to there. Actually, no, let's take it back a little bit far. Oh, too far. Undid all of them. We did undid all of them. So let's do it to here. Because after this, it starts to really flatten out. Actually, that's after this. No, we undid the real bad part, but it just seems a little flat right here. So let's see what we can do with the contrast. Curves transformation. Bring up the contrast. Let's not do that. Let's close this out. Sorry, I'm center of that. I don't know if it bothers you as much as it bothers me. Histogram transformation. Preview. Pull that up. We're just building contrast here. Okay. It's gotten rather noisy at this point. It's just, you know, there's not as much detail as I think my telescope now would do. Like I said, this was the DSLR. So I'm going to reshoot this at some point, but it's fun to play with the old files and with the new techniques. Let's go ahead and run Noise Exterminator on this because it's just getting a little noisy. Let's run it at the default and see what we get. Because I'd like for this to kind of coalesce. So if it blurs the background a little bit, which is what noise reduction does, that would be fine with me. And that is actually, it's exactly what I wanted it to do. It's actually bring up the detail a little bit and down the noise reduction a little bit, but we're on the right path here. Okay, good. Actually, nope, that's eggshell. My whole background is eggshelly now. That's not going to work. That particular. So we're just going to leave that alone for now. Let's do a red mask. Try to bring up those reds some. I only got the middle. What's it going to do in a magenta mask? Absolutely nothing. So we'll go to our backup utilities, color mask underscore mod, and we will zoom in. How do you zoom in? Reset zoom. I'll be honest, I don't use this enough. I don't know how to zoom in on my image. Where is it? Okay. Interesting. Okay. So what we'll do is we will attempt to click on the red area in the middle. And we'll know that's blue. You can see the little line shows up here. So that's blue. Let's get it onto a red. Oh, there. That's one of the areas. No, that's not one of the areas. Oh, look, we zoomed in. Okay, that's how you zoom in. You draw a box. Well, learn something new every day. So it's not picking up this reddish, slightly red hue. It's picking up all the blue hues. Zoom in some more. It's just making smaller boxes now. We really want it to pull. Okay, let's try something else. Let's make a copy of this, saturate the crap out of it, and try again. Try to get some more difference between the red and the blue. And let's pull down the blues. Try to leave the reds saturated more so we can pull more of a red so we can pull that center core out. Still doesn't like it. Still reads it as blue. My eye, that's weird because my eye reads it as red, but Pixinsight reads it as a blue shade. That is really interesting. So here's our clone. Let's try to build a mask off of this. Script, utilities, color mask underscore mod. Let's draw our line, draw our box, and right there. Okay, well, it's just not going to do it. So let's let's narrow in our focus so we try to create some definition in there. Right there. So that's all we're going to do is that really little speck. And we're not going to blur it very much because we want to be pretty precise. Let's see what we get here. We almost get the opposite of what we want. This is where the red is. Interesting. Let's invert that mask and Control I to invert. And let's add it to our original that's not sacrificial. Oops. That actually might just do it because we've protected the blue and we're getting those spots. That actually might work. Let's go into curve transformation, pull up a real-time preview, pull up our red. I want that to be more red. So there we go. And we take the background back down. And look at that. Would you look at that? Alright. Let's accept that. Ooh, I kind of like that. I shouldn't. It's so bold. Maybe a little bit less. I like the boldness though. Let's close out of that. Close out of the real-time preview. Mask, remove the mask. Now our background has gotten a little green. So let's pull back up the background neutralization. Let's create a new preview. Let's pull out that green. Region of interest from preview. Preview 1. And let's give it a go. Perfection. This is working out better than I expected. Preview, delete, preview. Alright. That is great. That's 100% right there. Let's do a cyan mask. That's perfect. Let's blur that mask a bit so we don't create any. Oh, let's just blur it to once. Oops, I missed. Process, all processes, curves transformation, real-time preview. We want our blues to be more, our blue-greens to be more intense. Okay. Do we like them this color, or do we want them a little less green? Let's see. A little more blue. Let us do one thing at a time here. Let's apply this, reset this. Now let's just work on the blues alone. We want to raise this color, which is right there. You saw the little line on the graph. So we'll just make it more blue. And right here is way up high. Let's make that a lot more blue. Now let's take our greens and take them down in that bright. That looks nice. Accept that and reset. Let's take our saturation and lower our background saturation. Our low point, let's see, that didn't work. Let's remove that dot. Background is roughly in this general area. So let's take some of the saturation out. Yeah, it's not enough. There's not enough definition. Let's see how it looks with the stars. Where'd my stars go? There they are. Close the mask. Yes, it's okay to be broken. Let's remove this mask. That's probably not a good mask to close, but I closed it anyway. Let us put our stars back in with Pixel Math. Let's rename this to Starless. It's less data to type here. Let's go ahead and create a new image and let us add those stars in. Let's hide our stars. We don't need them anymore. Can't close them, but we don't need them. That looks, that's 100% right there. That looks pretty nice. We didn't pull out much of the wing, but it just isn't there. It's just not there, I don't think. So our background looks pretty good. Our stars look pretty good. Let's go ahead and crop this in a little bit more so we get a little bit more emphasis on the galaxy. on the nebula, not the galaxy. Sorry, it is 2:30 a.m. on a cloudy night. (960 by 960). Let's try that. The way it shows better. Stars look a little wonky, but they were wonky, so they are what they are. It's our sacrificial clone. Close that. So this is what we have now. Let's look at what we had before. No. There. So our goals were to make it look better. I think it does. It's got a lot more definition in the interior of the nebula with the red, whereas this is kind of washed out. The wings are actually a little bit less visible, but this is really just a wash. It's just a green glow. It's not even the right shape. It's just a glow that I think I created somehow by accident. Well, you can kind of see it in this one, but where you can see how it juts out here, and it's pretty darn close to the nebula here, and you can see the wings, but it's really not. It's just not enough there to bring out. Whereas here, it's just a general glow around. So I'm not even sure I brought out what I wanted to in the original photo. You can see this. The sky is much more neutral, less noise. So overall, I'd say we did a really big success here. And this is an object I'm going to shoot again with my new telescope. I'm going to drizzle it so I can get a bigger image rather than this 960 by 960 square crop. So I've got targets for the future. That's always nice to have. So hope you enjoyed today's tutorial, and I will see you next time. Bye-bye.